Let's start the lecture today. Our time remaining is about 15 minutes. Okay. So today we are going to start this lecture 4. That is, this is the third week, and we will be talking about the open methods for finding the roots of nonlinear equations. So this is the chapter 6 of the textbook. So at the start, do you have any questions?
No. I have a question about the assignment. So it is already posted on Moodle and we should finish it by the next week, yes?
Yes, by
Understood.
next Sunday morning, evening.
Okay.
Yeah, and for those of you who are new, you must submit your assignment on the Gradescope system. So you should have received some invitation from the Gradescope to join that course. If you have any confusion or difficulty, you can contact me.
I have a question. So our assignment should be like, uh, should we include the MATLAB? We do it by hand. We should do it by
Yes,
MATLAB.
so this assignment you should do by hand. Yes.
Oh, okay.
By hand, I mean, yeah, you can do some tape. For example, if the question is very long, so maybe you can just show the first three iteration by hand calculations. And the remaining calculations, maybe remaining iterations you can use, you can show from the results of your Excel program.
The thing is that some of the problems ask us for graphical representation. So,
Yeah, so you can plot the graph by whatever software,
oh,
Excel
okay.
or I mean, Mathematica or MATLAB, whatever software you can plot. Yeah,
Okay,
plotting
okay.
of the graph is not by hand. Plotting of the graph should be done by the software. But some of the calculations, especially for the first three iterations, should be done shown by the hand calculations. And the remaining, if the calculations are long, then you can show the Excel results. Clear?
Yes, that's clear.
Okay. So today we'll be talking about the open methods of the root finding. Okay. So the name of the chapter is open methods. Uh, so why open methods? Because in the previous chapter, we considered the bracketing methods. The difference, so the opposite methods are open methods are different from the bracketing methods because in the bracketing methods you have a, you are sure about a root between the two limits, upper and lower limits of the x values or the independent variables. Whereas in the open methods, they are based on formulas that require only a single starting value of x or two starting values that do not necessarily bracket the root. So in this case, the roots do not bracket it. That means there is no, uh, it is not sure that, or it is not necessary that the root have to be within the two selected points. Okay, so they follow certain formulas to arrive at the roots. So this can you can see in this figure. Okay, this figure on the left hand side is figure A. So this is the example of a bracketing method. Okay, on this figure A. As you can see that in this figure, there are two limits, XL and XU. So on XL, there is a negative of this function, negative value of the function, and on xu there is the value of the function is plus. So by the bracketing method, then you take the uh, and then you by the bracketing method you take the average of these two values, or in the false position method you do it by the linear interpolation. But anyway, you reduce the bracket to the narrower range, okay, and then this bracket is further narrowed down, and then this bracket is further narrowed down, and until and then you get to the root of the equation uh, within the prescribed limits of your error. Uh, and in this case, in all iterations, the root remains inside of the bracket, inside of these lower and upper limits of the roots. However, in the open method, it is not necessary that you should bracket the root. Okay, so in the open method, you start from a value xi, okay, and then you can move to a value, say xi plus 1 to the next one. So which this xi plus 1 value may be closer or away from the root of the equation. So in this case, in B, you can see that from xi, you are moving to xi plus 1. Then we are moving away from the root of the equation. And here you can see that, and then it is taking it into to some other direction. So in this case, this is the example of the open method. However, this is one of the drawback of the open methods is that the open methods are not guaranteed to be convergent. So this example, this figure B is the example of the open methods in which the method is not converging, it is diverging. So in this case, this method will fail to provide us the solution. However, when open methods are sometimes, when open method is converging, the solution is obtained rather quite rapidly compared with the bracketing method, such as in this example C. So in this example C, from xi, we move to this point xi plus 1, which is not very far from the root of the equation. And then from here, we move towards the root of the equation. Okay, so how we move towards the solution or the root of the curve, it depends on the type of the open methods. It depends on the algorithm or the procedure of the open methods. So there are several open methods. So the first one is the simple fixed point iteration method. So simple fixed point iteration method is the first of the open methods. So how does this method work? This method works by rearranging the function so that x is on the left side of the equation. Okay, so we have the equation fx is equal to 0, and if this equation will have several x terms, so we rearrange this equation in a way that on one side we have only a term which is called as the x, and remember that x is the term which we want to know, that is the root. So we rearrange the function in such a way that the function fx becomes another some function gx, and the only difference is that on the other side the value x remains. So by some formulations, by some iterative methods, we can show that for the iteration purposes, the next iteration of x, that is xi plus 1, can be found by the previous value of x when we input into the g. So this method is applied iteratively to find the root of the equation. Okay, so let's see it with the help of the examples. So as we have told that the bracketing methods are convergent methods. Yeah, but all the bracketing methods which we previously discussed in the chapter number 5, they were the convergent methods. But bracketing methods are normally slower than the open methods. So in this case, the fixed point methods sometimes diverge, okay? And depending on the starting point and the initial guesses and how the function behaves. So as we have seen in this example B, so it can diverge, okay? So let's see the examples for the fixed point iteration. So suppose if the function is x square minus x minus 2, where we can say that x is greater than 0. So this function, if we want to write this function x square minus x minus 2 in this form, x, so there should be an x on one side of the equation and all the remaining terms should be on the other side. Okay, so this there are several ways to write this. So one of the ways that we can write it like this. So x square minus 2, and then we take x on the other side. So in that way, then that function gx will become x square minus 2. Okay. Or another way can be like that. If we take minus x minus 2 on the other side of the equation, and then only x square remains over here, we take the square root of that. So it will become x is equal to square root of x plus 2. Okay. So this is another form of the equation which can be used for the simple fixed point iteration. And another third form of the equation can be written like this. 1 plus 2, gx is equal to 1 plus 2 over x. Okay. So for example, if yeah, so you can easily show that it can be written as like 1 plus 2 over x as well. So for example, if you take x square minus x plus 2, so if you divide all these terms by x, so it will be x minus 1 minus 2 over x, right? If we divide this, if we take this equation and divide by x, okay, so it will be x over here, it will be 1 over here, and it will be 2 over x over here. So 1 and 2 over x you can take on the other side, and then x remains over here. So x is equal to 1 plus 2 over x. So several types can be written, and then those types can be used for that purpose. Okay, so in this case, then the simple fixed point iteration method can be used in one of the several different ways. So how to apply this fixed points iteration method? So this can be, we can apply this fixed point iteration method for this type of equation. So for example, if we want to find the solution of e power minus x, okay, the function can be separated directly and expressed in the form of equation 6.2 as this. So for example, if we take this function as e power minus x, we can just take x on the other side, and then it will be e power minus x. And then we put the subscripts of I x as with x with the function of gx, we will put a first subscript of xi. And with x, we will put a subscript of I plus 1. And then we can start with the initial guess of x is equal to 0. Okay, so we have to make some initial guess. And the iterative equation can be applied, and then we can get the result like this. Okay, so how we can get this result? This I can show in Excel. Okay, so for example, if I want to show you something like this. So the function is e power minus x. So if I take I, so these are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these are just the iterations. And then the values of xi. Okay, the values of xi, and then our function is e power minus x. Okay, so if it is if our function is e power minus x, so we start from 0. Okay, we start from 0. Then our next iteration will be e power minus x. So it will be equal to e is represented by exp, and power minus x, exponent minus this value. So it is this. So this, after the first iteration in this method, the value will be 1. And then if I repeat it, after several iterations, the values will be like that. Okay. So how much value, how much these values are different? So we can find it by the true error. But for the true error, we need to have the true value. Okay. True, T-R-U-E, true value. Okay, so what is the true value? So true value we can find by the, also by the trial and error, or by the, from the Microsoft Excel. So because our equation is, okay, remember that our equation is something like this. F of x is, for this equation, for this question, the equation is this, e power minus x minus x. Okay, so it is e power minus x and then minus x. Okay, this is just for your indication. So if we want to say, if I say, for example, the value of x is 0, so what will be the value of function? Value of the function will be exponent of this 0, minus exponent of this value, and that is minus this. So for value of 0, the value for the value of x, the value of function is 1. So what will be the root? So root of this function will be the value of x, for which the value of x should be 0. Okay, so maybe I can try 0.6. So now I can see that by the trial and error, I can see that I can find a very close value. However, we can use Microsoft Excel's solver add-in. So for example, data, and here I have the solver add-in installed, okay, in Microsoft Excel. So in the solver, I can now specify set the objective. So what is the objective? Objective is this value. So the objective is this function I must make equal to 0, and by changing the values of this function. Okay, by changing the values of this function. So in this case, now I will click the solve button, and then it will say that it has found the value, and which is equal to 0.56714. So this is the true value. Okay, so this is the true value by the all precisions which the Excel can offer to us. So what is the true percentage error? So true percentage error over here is this true value. Okay, I will constrain it minus the estimated value divided by the true value, and multiplied by 100. Okay, so it is the true percentage error, of course, over here is 100. And then I subtract it down, so I will see that this is how the true values goes. And then it will be better to take the absolute values. So yeah, so also that all the figures are plus. So here I can see that by the 9th iteration, the true value percentage error is 0.399. Okay, by the 10th iteration, the absolute true value is 0.399. And now I can see that if you see from here and here, so you can see that we got the same values. Okay. Yeah, so 0.399 here, 0.399 here. Okay, so our results are matching. Okay, and then similarly we can also find the uh, uh, approximate percentage relative error as well, and the final results are 0.564879. Okay, so in this case, then we can see that after the 10th iteration, we have found that 0.564879 is the root of this equation. So thus each iteration brings the estimate closer to the true value of the root, and which is 0.5714. So it is bringing it closer. Although the error is 0.399%, which is not too much. So it means that we are slowly uh, getting closer to the root of the equation. So in this case, this was the example of the simple uh, fixed point iteration method. And you can see that by this method, we can come closer to the root of the equation. And we will, and then the coming closer to the root of this equation is rather quite slow. So
I have a
anyway, so
question.
we will continue this
I have a
in
question.
our next lesson. Yeah. Any questions?
Yes, so when we are dealing with the function, shouldn't we give like estimate, not estimate, but look to the approximate percentage error, not the true error, like in real life situation, because we usually will not have true value error. Yes.
Yes. In the real, for those unknown function, then we will not have the true value. So we should look at the approximate percentage error.
So in this case, is the approximate error of 1.1% like bearable enough for our case?
No, it should be lower. It should be less than that.
Oh,
Should be
okay.
normally it should be uh, less than 0.5%.
Okay.
But only we have shown up to for the 10th iteration.
Also, when we are using the open, like simple fixed method, fixed point iteration, uh, our initial guess should be uh, like we should do our initial guess looking at the graph, as I understood, to make a better
Y-
assumption.
Yes.
Okay.
So fixed point iteration method depends very much on the how you have chosen the initial value, and what is the shape of the equation which you are using, which type of function g of x you are using. So for example, uh, uh, in this case, there are three different possibilities. So some of the formulations will give you quicker results, but some of the formulations may not give you quicker results or may even diverge as well. So simple fixed point iteration method depends not only on the initial guess, but also the form of the function gx as well.
Okay. Thank you.
All right, then see you all on Wednesday.
Goodbye.
Bye.